A few examples. So the volume V of R in cubic meters of a sphere of radius R meters is given by V of R 4 over 3 pi R cubed. Given that the radius increases from 2 meters to 3 meters, determine the average rate of change of the sphere's volume with respect to its radius. So these are the endpoints, and we're working out the average rate of change, which first of all means we need to work out the matching coordinates that go with it. So we need to work out V of 2, and we also need to work out V of 3 to do the average. So let's do that. So for V of 2, we get 4/3 pi times 2 to the 3. 2 to the 3 is 8. 8 times 4 is 32. So we get 32 pi on 3. And for the volume at 3, we're going to get 4 on 3 times pi times 3 to the 3. 3 to the 3 is 27. 27 divided by 3 is 9. 9 times 4 is 36 pi. All right, so we've got our two endpoints. Now we can start comparing them using the average rate of change. So it's going to be the y coordinates on the top over the difference in the x coordinates. So 36 pi minus 32 pi on 3 all over 3 minus 2. Alrighty, so in order to evaluate this, firstly, mostly going to have to worry about the top. 36 pi is not in thirds, so let's make it in thirds. 36 times 3 is 108 pi on 3 minus 32 pi on 3 all over 1. Well, dividing by 1 does not do much, so we don't have to worry about that. 108 minus 32 is 76 pi on 3. Alrighty, so that is the gradient there. So it's the average rate of change between 2 and 3 meters of radius. In order to do part B, to do the instantaneous rate of change, well, we first of all need to work out V dash of R. Alrighty, 4 over 3 pi is just a constant, so the only part that actually needs to be derived is the R to the 3. R to the 3 comes down the front, and R to the 3 becomes R to the 2. The 3 times the 3 cancel, so we get 4 pi R squared. So that is the function of V dash, and now we've just got to substitute in V dash of 3 meters. So it's going to be V dash of 3, 4 times pi times 3 squared, which is going to be 9 times 4, which is 36 pi. So the average rate of change is 76 pi on 3, and the instantaneous rate of change is 36 pi. Let's have a look at a slightly different situation where we might use this. So if the height h meters above the ground level ball thrown upwards at time t seconds is given by h equals negative 5t squared plus 20t plus 6, where t is positive or greater than or equal to 0, calculate the time and height in which the rate of change in height is 0. So just remember, rate of change is meaning dh dt, and is 0 is 0. So we're waiting for the rate of change is 0. So let's first of all work out dh dt. Bring the 2 down, 5 to the t to the 1. 20t derives to 20, and 6 derives to nothing. So we are left with minus 10t plus 20 as our derivative function. But we're interested when h of dh dt is equal to 0. So substitute in 0 is equal to minus 10t plus 20, and rearrange, solve for t. So we get minus 20 is equal to minus 10t, divide both sides by minus 10, and we are left with t is equal to 2. So therefore, at time 2, the gradient is equal to 0. But it also wants us to calculate the time and the height. So we now need to go back to the original function to work out the height. So let's do that. So sub t equals 2 into h, and we get h is equal to minus 5 times 2 squared plus 20 times 2 plus 6 2 squared is 4, so we get minus 20 plus 40 plus 6, which is 26. Alrighty, so when the ball is 26 meters high and at 2 seconds, the gradient is 0, or the rate of change is 0. Alrighty, thank you for watching. See you in the next one. Bye.